Hello students, welcome back. Today we'll be discussing about the ecological succession. This is Professor R.M. Mahendrakar from JSS Arts, Science and Commerce College, Gokak. E. Lucy Burns says, vegetation is a dynamic and ever-changing complex now appearing quiescent and in complex equilibrium with the habitat, now displaying an obvious evidence of change. Observations of the natural changes in vegetation long ago resulted in the concept of succession. The term succession was coined by Hult in the year 1885 for the orderly change in the communities. According to Salisbury, plant succession is a competitive drift in which at each phase until the climax, the constituent species render the habitat more suitable to their successor than to themselves. According to E. P. Odum, plant succession is an orderly process of community change in a unit area. Clements gave a very simple definition of plant succession. According to him, succession is a natural process by which the same locality becomes successfully colonized by the different groups of communities. Succession is a complex universal process which begins, develops, and finally stabilizes at the climax stage. The climax is the final, mature, stable, self-maintaining, and self-reproductive stage of vegetational development in a climatic unit. Succession is generally progressive, and thus it brings about progressive change in the soil conditions or habitats. These changes brings the habitat from extreme to optimum conditions for plant growth. Based on different criteria, there are following kinds of succession. Primary succession, if an area is of any basic types, that is terrestrial, freshwater or marine, if it is colonized by organisms for the first time, the succession is called primary succession. Thus, primary succession begins on a virgin land, that is, an area not occupied by any previous community, such as newly exposed rock or sand dunes, where the constituents of the existence may not be favorable initially. It may take hundreds of years before a climax community gets established. Second, secondary succession. When the succession starts from a previously built up strata, which was once occupied by original vegetation but later disappeared due to certain forces like the sudden change in the climatic factor, fire, strong wind, rain, or some other biotic intervention, then it is called secondary succession. Usually, the rate of secondary succession is faster than that of the primary succession because of better nutrients and other conditions available in the area. The third, autogenic succession. When the succession begins and if the community itself, which as a result of its reaction with the environment, modifies its own environment and thus causing its own replacement by new communities, this course of succession is called autogenic succession. That is, here the principal force of change comes from within the community. Allogenic succession. In some cases, succession is driven by forces primarily outside the community. This is called allogenic succession and it may occur in a highly disturbed or eroded area or in a pond where nutrients and pollutants enter from outside and modify the environment and in turn the community. Autotrophic succession. It is characterized by early continued dominance of autotrophic organisms such as green plants. This type of succession is widespread in nature. Heterotrophic succession. It is characterized by early dominance of heterotrophic organisms such as bacteria, actinomycetes, fungi, and animals. It begins in a medium which is rich in organic matter such as small area of rivers, streams. These are polluted heavily with sewage or in small pools receiving uh, litter in large quantities. In ecological literature, depending mainly upon the nature of the environment where the succession has begun, these are the different types of successions. The first, hydrosere or hydra, means here the succession starts in those areas where there is plenty of water. For example, ponds, lakes, streams, swamp, bogs, etc. The second is mesak. This is the type of succession which occurs in those areas where there is adequate quantity of moisture. And the third is xerosere or xerac. This is the type of succession which occurs in those areas where the water is minimal, that is, there is very less quantity of moisture available. For example, dry deserts, rock surfaces, etc. So first let us study hydrosere. If the water body is large and very deep, or very strong waves action and other powerful physical forces are at work, the succession results in a stable aquatic community in which any further considerable changes are hardly seen. Hydrosere succession is recognizable only if the colonization of the plant community takes place in artificial, small and shallow ponds, lakes, etc., where the wave actions speed up the process by allowing the erosion of the soil towards the edge region. In this way, the filling process also speeds up quickly and subsequently the body of the water disappears within a few years' time. In a new and virgin pond, hydrosere starts with the colonization of phytoplanktons and finally terminates into a forest. So how the hydrosere occurs, that we shall see step by step. The process of aquatic succession completes in following stages. First, phytoplankton stage. Second, submerged stage. Third, floating stage. Fourth, reed swamp stage. Fifth, meadow stage. Sixth, woodland stage. Seventh, climax forest. And eighth, climax woodland. Now let us see each of these stages in detail. The process of aquatic succession or hydrosere starts with phytoplankton stage. In the initial stage, the algal spores are brought in the body of the water. The simple forms of life like bacteria and algae and many other aquatic plants called phytoplanktons and animals, zooplanktons, float in the water, which are the pioneer colonizers. As these organisms add a large amount of organic matter and nutrient due to their various life activities, and after their death they settle at the bottom of the pond to form a layer of muck. Now here this is the diagrammatic section of the hydrosere. Now here at the surface you can see there it is the phytoplankton or zooplankton. And as they die, in absence of oxygen, the toxic gases and muck accumulate at the bottom and rises the level of the pond. The second stage is the submerged stage. The phytoplankton stage is followed by submerged plant stage, where a loose layer of mud is formed on the bottom of the pond. Some rooted submerged hydrophytes begin to appear on the new substratum. The submerged aquatic vegetation develops in the region of the pond or lake where water depth is about 10 feet or more. The pioneers are Elodia, Potamagaton, Myrophyllum, Ranunculus, Utricularia, Ceratophyllum, Valesnaria, Cara, etc. These plants form tangled mass and have marked effect upon the habitat. When these plants die, their remains are deposited at the bottom of the pond or the lakes. The eroded soil particles and the other transported materials also get deposited at the bottom. This gradually raises the bottom of the pond and lakes. As this process of stratification progresses, the body of the water becomes more and more shallow. Consequently, the habitat becomes less suited for submerged vegetations but more favorable for other plants. Now the third stage is the floating stage. Means as the ponds become shallow or the lake becomes shallow and the depth reaches about 4 to 8 feet, the submerged vegetation start disappearing and from its original place, and then the floating plants make their appearance gradually in that area. In the beginning, the submerged and floating plants grow intermingled, but in the course of time, the submerged plants are replaced completely and the most tolerant species in the area are able to produce and perpetuate. The broadleaf floating on the water surface check the penetration of the light to the deeper layer of the water. This may be one of the reasons why the submerged plants start perishing. Due to the continuous interaction between the plant communities and aquatic environment, the habitat becomes changed chemically as well as physically. More water and airborne soil particles and dead remains of the plants are deposited at the bottom. Thus, the substratum rises up in vertical direction. Important floating plants that replace the submerged vegetations are this Lilimbum, Trapa, Pistia, Nymphia, and Limnanthemum. The next stage is the reed swamp stage. When the ponds and the lake becomes too shallow, that is, water depth reaches around 1 to 3 feet, the habitat is changed to such that it becomes less suited for the floating plants and more suited for the amphibious plants. Under these conditions, the floating plants start disappearing gradually and their places are occupied by amphibious plants which can live successfully in an aquatic and well aerial environment. The important amphibious plants that make their appearance in this reed swamp stage are this Botricolova, Typha, Pragmatis, which we commonly call it as a reed, etc. The foliage leaves of such plants are exposed much above the surface of water and the roots are generally found either in mud or submerged in water. The foliage leaves form a cover over submerged and floating plants, and thus they cut off the light from the plants underneath them. Under such conditions, neither submerged nor floating plants can survive. The next is the sedge marsh or meadow stage. The filling processes finally results in a marshy soil which may be too dry for the plant of pre-existing community. Now the plants well adapted for the new habitat begin to appear in the pre-existing community in a mixed state. The important plants that are well suited to marshy habitats are the members of Cyperaceae and Gramineae. The species of sedge, then Ruscus, that is the Juncus species, Tremeda, Iris, Dicanthemum, Europhorum, Combopogon, Campanula, Mentha, Caltha, Gallimum, Turicum, and Cicuta, etc. are the first invaders of marshy area. As these plants grow more luxuriantly in the marshes, they modify the habitat in several ways. They absorb and transpire large quantity of water and also catch and accumulate plant debris and wind and waterborne soil particles. Consequently, a dry habitat results which may be totally unfit for the growth of normal hydrophytes. Gradually, the mesophytes start appearing, and after some time, the sedge vegetation is totally replaced by the mesophyte. Woodland stage. In the beginning, some shrubs and later the medium-sized trees form the open vegetation or woodlands. These plants produce more shade and absorb and transpire large quantity of water. Thus, they render the habitat more dry. Shade-loving herbs may also grow under the trees and shrubs. The prominent plants of the woodland community are this cassia, acacia, terminalia, salix, Siphalanthus, etc. Climax stage, that is the climax forest. After a very long time, the hydrosere may lead to the development of climax vegetation. As the level of soil is much raised above the water level by progressive accumulation of humus and soil particles, the habitat becomes more dry and certainly well aerated. In such habitat, well-adapted, self-maintaining and self-reducing, newly stable and uniform plant community consisting mostly of woody trees develop in the form of mesophyte forest. In the climax forest, all the types of plants are met with: herbs, shrubs, mosses, shade-loving plants represent their own communities. Trees are dominant and they have control over the entire vegetation. Bacteria, fungi, and other microorganisms are more frequently found in the climax vegetation. They react upon the habitat and make the soil rich in organic material. As the climax stage, a complete harmony develops between the plant community and the habitat. The last stage is the climax woodland. Climax trees species include the oak, ash, and beech. They are slow growing, but because they are also tall and long lived in time, they become to dominate an area. The particular climax tree species which eventually dominated the woodland would depend on soil types and other environmental conditions. The number of species making up the woodland community is very dependent on the structure of the wood and on how much light gets through the woodland floor where the ground is too heavily shaded. Herbs such as wood anemone and wild garlic will flourish. Now this is a diagrammatic wave of the hydrosere. Now this is the planktonic stage, this is the submerged stage, this is the free floating stage, and the invasion of the reed and swamp. Then this is the stage where the marshy and the woody tree starts appearing. So my dear students, I complete this topic on the ecological succession with an example of hydrosere. So, thank you once again for your time. Take care of your health and be safe.